Today and tomorrow we'll be finishing up this week by looking at lesson 92. We're going to go back and discuss a concept that we've hit a couple times this year about our quadrilaterals, but in today's lesson we're going to see these quadrilaterals on the coordinate plane. What the goal is on today's lesson is we're going to be given some information about the picture. We're going to be given specifically the points or the corners that we have on a certain quadrilateral, and our job is to determine what kind of quadrilateral do we have on the question. So just kind of, you can see where we're going to go, and we'll look through a couple different questions together. You're going to be given the vertices, you're going to be given the corners of the question. What your job is, as I just mentioned, given those vertices, given the corners, you're able to determine the kind of quadrilateral that you have based on some properties that we're going to see on the Cartesian plane. Now, if you were to look back in your textbook, these were two of the main lessons that we talked about quadrilaterals already, lessons 61 and 65. And within those two lessons, you'll see some of the different properties that we'll be hitting in our lesson today. I'll try to mention as we're going through the question what the property is that we're looking for, as you'll be looking for the same property as you're doing your homework questions tonight. Now, as we're doing these questions of trying to show what kind of quadrilateral I have, a visual evidence is not just the same as mathematical proof. I can't say, oh, okay, well, it looks like a parallelogram, therefore it is a parallelogram. It looks like a square, so therefore I think it is a square. I actually have to show mathematically, using some formulas, using some equations, that that actually is the case in our question. My answer has to be supported with some calculations, with some work. I can't just say, yes, it's this, or no, it's not this. I have to actually show or prove that that is the case in our question. Now, to help us with our calculations, there's going to be two main formulas that we're going to be using here in lesson 92. One we're going to focus in more today, and that'll be the first formula I'm going to show you. The second one we'll see during tomorrow's lesson as we finish up our questions. The first formula that we're going to focus on for today's lesson is our slope formula. Remember the slope formula, it was a fraction. There was a couple different formulas that we had for slope, like we had rise over run if you were going to graph. But the formula that we're going to be using in our lesson today is m, that's our abbreviation for slope, is equal to y2 minus y1 over x2 minus x1. Remember those x's and y's represents points. So you have two different points that are given to you in the question. So sometimes even in class we labeled our points. Here's my point 1, so we called it x1, y1. Here's point 2, so we called it x2 and y2. You guys might want to do the same thing as well in our lesson as we're working through these questions. So make sure you jot that formula down, as that's one we're going to focus in on all of our questions today. On tomorrow's lesson, we're going to be using the distance formula to help us show or to prove that something is actually the case. The distance formula was the giant square root that we learned about earlier this year. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, make sure you get that formula down. We'll see that during tomorrow's lesson about how to correctly use that to prove or to show that a quadrilateral is a certain kind of quadrilateral in our question. Now, going back to today's formula with our slope, here's two concepts that we're going to be looking for when it comes to our slopes of certain lines in our question. If you notice, maybe you think these lines are parallel to each other. So maybe you're trying to show that something is a parallelogram. Well, what did it mean that you had a parallelogram? You had two sets of parallel sides. Well, then I need to show that the slope of this side is actually the same as the slope of this side, and I need to show that the slope on the left is the same as the slope on the right. That's what it means that lines are parallel to each other. They have equal slopes. So I would use the slope formula twice, one on the top, one on the bottom, and I better get the same answer out of both of those. Well, then I would use the slope formula two more times, one on the left, one on the right, to make sure that those segments are also parallel to each other. What if you're supposed to be determining if lines are perpendicular to each other? What did we learn about slopes of perpendicular lines? They were negative reciprocals or opposite reciprocals. What did that mean? They were negative. One of them was a positive ratio. One of them was a positive slope. One of them was a negative slope that you had in the question. What does that word reciprocal mean? They're flipped upside down. So if one of the slopes was positive 2 over 3, well, then the negative reciprocal would say negative 3 over 2. I had one positive, one negative, and I flipped the fractions upside down to help us come up with our questions. Now, in your work packet this week, you should have received a sheet of graph paper, so please go ahead and take that out for me. Go ahead and fold it up into your different sections. We're going to be working with 2 different graphs today. We'll see one graph tomorrow, and you'll also see some graphs that show up in your questions on your homework. Now, the ones on the homework, for the most part, are already graphed out for you with a picture. If they're not already graphed for you, I would encourage you to graph them first, like we're going to see here in our lesson today. So go ahead and jot down this first question for me. The vertices, again, that just means the corners. The vertices of quadrilateral EFGH. And I haven't said yet because I'm assuming we know, but just to remind ourselves, what's a quadrilateral is something that has 4 different sides. Okay, so that's what we have a quadrilateral. So at the vertices of quadrilateral EFGH are, point E is located at 1, 6. Point F is located at 5, 7. Point G is located at 3, 1. And point H is located at 7, 2. Our job is to determine, is this quadrilateral also an example of a parallelogram? What did that mean from our previous lessons, from lessons 61 and 65, that I had a parallelogram, the opposite sides were parallel to each other. So how am I going to show that the opposite sides are parallel? I need to show that the 2 different sections that are across from each other have the same slope. So we're going to end up using the slope formula 4 different times on this question. We have to show the top and bottom have the same slope, and we have to show that the left and right also have the same slope in our question. Now, as I mentioned, if the problem is just written in words like this, which you do have in a couple of your questions tonight, the first thing you want to do is draw the picture. Put these different ordered pairs on the problem and then connect them in the same order, E, F, G, H. Well, how do we graph an ordered pair? The first number goes right and left. The second number goes up and down. So to graph 1, 6, you would need to go right 1 and then up 6 spaces. Then you would put a dot and you could label that with the letter E. The second one for F, I would go right 5 and up 7, and you could proceed to do that for letters G as well as for letter H. Now, something I would encourage you to do, and I did the same thing here on my picture, after I graphed each one of my ordered pairs, not only did I put the letter next to the point that I just put, I also put the parentheses so I can see the numbers that I'm going to be using in the question. Then I don't have to keep looking back at the original problem. I can see them right here on the screen. You can see them right there on your Cartesian plane as well. So what was I trying to show? We're trying to prove that this shape is a parallelogram. So I can't just say, well, okay, it looks like it's a parallelogram, so okay, that's good. I'm just going to say it is. We have to show mathematically that this is actually a parallelogram. So how did we do that? We need to show we have 2 sets of parallel sides. So I'm going to begin with the 2 slanted pieces, the one on the top and the one on the bottom, and I need to show that those are parallel to each other. To show that they're parallel, I need to identify that their slopes are the same. So let's begin. Here's my little m for slope, and that little subscript at the bottom, EF, that just shows I'm using the top part of my picture. What's the slope going from E to F? For our slope definition, the slope formula was y2 minus y1. So I picked the y that was at a point F, subtracting the y that was at a point E. Now, if you wanted to go 6 minus 7, that's okay. Just make sure that you're consistent. You always start at E and then go to F, even as you fill in the denominator. I decided to start at F and head over to E in the question. All right, so what do I have? We have 7 minus 6 from the y's and 5 minus 1 from the x's. When I subtract those, 7 minus 6 gives me 1, and 5 minus 1 is 4. That fraction doesn't reduce. Slope is always written as a fraction, so we don't want to do anything else in that question. Now, what was I supposed to do with the slope of EF? I need to show that it's the same as the slope going from G to H. So that's the second thing that I want to look at in the question. Well, going from G to H, what numbers do I use? The 9 and the 6 The y's that I see in that point are 2 and 1. So I have 2 minus 1. I'm going from right to left in my picture. Then the x's that I see in this picture are 7 and 3. So 7 minus 3. If I subtract again, I have 1 over 4. Am I supposed to have 1 over 4? I am, because if this is a parallelogram, then those two pieces are parallel, which means they should have the same slope. So far, so good. It looks like I have a parallelogram. Now, just to mention, if you would have checked these first two sides and they're not parallel to each other, then I don't need to check the other two sides. On our question, however, these first two sides are parallel because they have the same slope. Therefore, I do need to check the other two sides as well. The next side that I checked was going from E to G on the left-hand side of the problem. So this time I started up here. I started down at G and I went up to point E. Again, you could start at E, headed down to G, just as long as you're consistent the entire way across the question with how you fill in the formula. The y's that I have are 1 and 6, so 1 minus 6, and then the x's are 3 and 1. When I do that arithmetic, 1 minus 6 gave me -5, and 3 minus 1 is 2. That fraction doesn't reduce, so I can't do anything with the first slope going from E to G. What's supposed to be the same as the slope going from E to G? The slope that was across from it, which is going from F to H. So the slope in our picture going from F to H. Again, I went from the bottom up to the top in my picture. So the y's that I was using were the 2 and the 7, so were the second numbers inside of each of the ordered pairs. Then the x's I was using was the 7 and the 5. When I subtract there, I get -5 over 2. Am I supposed to have -5 over 2? I am, because that was the slope of the piece that was opposite in the picture. Do I have everything I'm looking for? I do. We noticed the piece on the top and bottom had the same slope, which means they're parallel to each other. We just saw the pieces on the left and right-hand side also have the same slope. Therefore, they are also parallel to each other. So you would finish the question something like this. Both pairs of opposite sides are parallel. Therefore, I do have a parallelogram. That was the qualification of it being a parallelogram, was we've just proven mathematically that both sides were parallel to each other. Let's do one more example today with the same idea. This time we're going to try to prove that our shape is a trapezoid. So what does it mean that we have a trapezoid? There's just one set of parallel sides. So either only the top and bottom are parallel to each other or only the left and the right-hand side. The parallelogram was both sets had to be parallel to each other. Just like the last question, the first thing I would encourage you to do is to draw this picture out. As I'm drawing the picture out, remember, go right or left first and then up or down. So J would go right 1 and then up 2. Put your dot, the letter J, and then also that ordered pair of 1, 2. When you finish graphing those 4 different ordered pairs and connect them in the same order that the question gave them to you, so J, K, L, M, your picture should look like this. How do I prove? How do I show that this is a trapezoid? I need to show that I have one set of parallel sides. So what I'm going to do to start the question here is I'm going to begin with the pieces that are slanted across the top and across the bottom. To show that they're parallel, I need to identify their slope. So I began at the top going from J to K. Again, in my picture, I went from right to left as I filled in the formula. So the y's that I see are 5 and 2, and the x's that I see are 6 and 1. 5 minus 2 is 3, and 6 minus 1 is 5. So the slope going from J to K is 3 over 5. So now I want to check going from M to L. Is that slope also 3 over 5? Because then I would have at least one set that would be parallel to the other side. So let's check going from M to L. Again, this time I actually went from right to left as I filled in my formula, or left to right. Again, it doesn't matter as long as I'm consistent within this fraction. So the y that I used was 0 minus this y, 1, and then 4 minus 6 for the x's. 0 minus 1 gave me -1, and 4 minus 6 is -2. I have two negatives here, which means it turns into a positive, and 1 over 2 doesn't reduce, so I have 1 over 2 for the slope going from M to L. Did these two slopes match? No. Okay, so this is not my set of parallel sides. That doesn't mean, however, that this shape is not a trapezoid. Because remember, a trapezoid just had to have one set of parallel sides. Maybe this isn't the set. Maybe it's the other direction. So let's check those ones out. So I first started going from J to M. As I subtracted my y's, this one I went bottom to top. So I have 0 minus 2 for my y's, and then 4 minus 1 for my x. 0 minus 2 gave me negative 2, and 4 minus 1 is 3. So the first slope on the left-hand side of the picture is negative 2 over 3. Well, now let's check the slope on the right-hand side of the picture. Again, I went from bottom to top as I filled in my numbers. The y's that I have are 1 and 5, and the x's that I have are 6 and 6. When I subtract, I have negative 4 over 0. Well, that's odd because I'm not supposed to have a 0 in the denominator in math. That was called our undefined fraction. Well, is an undefined slope the same thing as a negative 2 over 3? It is not. So these two slopes also are not the same. We noticed on the previous slide, the first two slopes were not the same. Therefore, these sides are not parallel to each other. We just saw on this slide, the other sides are also not parallel to each other because they don't have the same slope. So what does this mean? This shape is not a trapezoid. I mean, it kind of looks like it is, but based mathematically, the slopes that I have from the opposite sides, none of them match. Therefore, they're not parallel, and I don't have the qualification for a trapezoid. So as you do your questions tonight, again, if there's not a picture, draw a picture out. What are you looking for? If it asks you to identify that you have a parallelogram, you need two sets of parallel sides. If you're identifying, do I have a trapezoid, then you would just need one set of parallel sides.